we're looking at energy in the biosphere. We're looking at Earth as being a closed system. So I'll explain that on the next slide a little bit more. The energy that the Earth receives does not cycle like matter does. So we'll talk about that in a little bit here. So an open system allows energy and matter to cross the system boundary. So it gets to enter and it gets to leave. A closed system allows only energy, but not matter to cross the system boundary. So we have energy that can be exchanged, that can come and go, but matter is not able to do that. So energy can cross our boundary, matter has to stay within our boundary. So here's another example here. This is the Earth. We have solar radiation, terrestrial radiation, and those can come and go as they please, but within that system boundary, that outer circle, all of the matter has to stay within it. The matter can't actually leave that boundary. So we're bound by the first and second laws of thermodynamics. You need to know all three laws, I believe. We definitely speak of 1 and 2. I don't know if we go to 3. Not that I'm seeing anyway. So as far as 1 and 2 goes, the first law, energy cannot be created or destroyed. It can only be converted or transferred from one form or object to another. So we never actually lose the energy, it's just transferred. Second law is with each conversion of energy, energy is lost. So there's less available energy at the next level. So it's not destroyed in it being lost. It's just transferred or converted to some other form. But there is always a loss from one level of energy to the next. So here's an example of the first law. Energy can't be created or destroyed, just transferred. We have an example here, a little bit more physicsy than you need to know for bio. I'll just explain what this picture is discussing here. Any thermodynamic system in an equilibrium state possesses a state variable called the internal energy. Between any two equilibrium states, the change in internal energy is equal to the difference of the heat transfer into the system and the work done by the system. So this is our heat transfer, this is the work. So the energy doesn't actually change, it just gets transferred to a different type of energy in the way that it's being used. So it's not like it's leaving the system, it's just being transferred or transformed into some other type. For the second law, with energy lost, usually we get it as heat or as like consumed energy. So this is why we don't need to continually supply new energy. If we had to, then we wouldn't be able to sustain life. So again, each time energy is converted to another form, some is lost, usually as heat. I'm not sure why it says unusually. It should say usually. So here are different ways that we have energy being transferred. And so it's just moving from one form to another. So it's not actually being lost, just being transferred. As far as consequences for our laws go, we lose energy as it's passed along the food chain. So a constant supply of energy is needed to sustain life. So that's where decomposers come in, and they're really handy to have because they allow that energy to be transformed as dead or waste matter into usable matter. So as a general rule, again, less than 10% of the energy that's present at one level is passed on to the next. We stick with 10, even though it says less than, 10 is our rule of thumb. So this will limit the number of trophic levels in an ecosystem to 5 or less, because once we get up to that 5th level, there's essentially no energy that can be passed on. We're at the end of 1.1, so you can do some review. It's on page 15 in your text. The questions are there for you if you'd like to spend some time going through them.